Kinematics means language for motion. Dynamics is a relationship between motion and the forces which causes. Force means push or pull. Hmm? Normal contact force means suppose we are standing on this floor means the floor gives a force which is equal to our weight, mass into gravity. Hmm? We are giving to the ground mass into gravity. An equal force is given by this ground. That is called a normal force, normal contact force. If it doesn't give, what will happen? Because of this mg, we will go inside the ground. We will go inside the ground. So to avoid that, a normal force is given by the ground that is equal to mg. That is equal to mg. That is called the contact force. Normal contact force. Friction force. Suppose we are moving, a vehicle is moving, a vehicle is or a mass is moving along this surface means its weight acting downward mg, and equal and opposite force is acting upwards, that is also mg. Uh, Suppose we are applying a force F along this direction, that's why this mass is moving towards the right means a left another force will act. That force is proportional to uh, frictional force. That is uh, frictional force, F frictional force, that is equal to mu mg. This normally, no, normal force multiplied by that coefficient of friction, mu mg. So these are the forces acting on a mass. This frictional force, when it moves or when it tends to move only, it will exist. This force will exist when the mass moves or when it tends to move. This mu, two values are there. Mu static, mu dynamic. The mu static means when it tends to move, that mu is called static frictional coefficient. This mu d is dynamic. When it is moving, its value is different. That is called dynamic mu. So, what are the forces acting on this mass? We should know. Uh, this is the applied force because of weight, the mg acting downwards. Uh, Equal and opposite normal force is there, that is acting upward, that is n equal to all mg. If the force is applied rightwards, then immediately opposite force will act, that is called mu n or mu n equal to mg, that's for mu mg. Whenever this force acts, this will act. Even though the force is not sufficient to move this body towards the right, then also this will act. That is called static. When the body moves, then this mu value is different. Okay. Tension in the stretched string. Suppose a mass is hanging from the wall, mass mg is acting downward. This is the string has some tensional force. That is upward force, that is also equal to mg. So tension in the string is mg. Non-contact force. We'll see then and there about non-contact force. Then Newton's first law. If you add all these forces, then it is sum is equal to 0. For example, vertical forces, if we say that mg is acting downward, let us take it as positive. And normal force acting upward, that is minus mg, equal to 0. Similarly, this f and mg are perpendicular to each other. That's why they are independent. There is no connection between them. There is no connection between them. Um, there is no connection between them. Um, that's why we have to resolve all vertical forces separately, horizontal forces differently. There is no connection between them. If you take all vertical forces, mg minus mg equal to 0. If you horizontal forces, F is applied force, opposite force is minus mu mg, that is also equal to 0. That is first law of motion. Uh, inertia means because of weight, a body hesitant to move. If it is moving, it is hesitant to stop. That is called inertia. This is proportional to its mass. Next, second law of motion, F equal to ma. Mass into acceleration is second law. This is true only when m is constant. Um, Third law, every action has a reaction. Every action has a reaction. So that's what this F is. Because of F, it moves right hand side means there is a reaction that is called mu mg. Mg is acting downward. For every action, there is an opposite and equal reaction, normal. Hmm? These are all sufficient. We'll see then and there. Hmm? Other theory we'll see in the physical independence of force as consequence of physical independence is consequence of first law of motion. So sum of forces equal to 0. Sum of forces equal to 0. So physical independence of force are consequence of first law. Shall we move to next sum? Shall I move to next sum?
Yes, sir.
Amrita?
Yes, sir.
Okay. We are going to say alternate sums because want of time. But I will give the question, solve yourself. If you have any doubt, you can ask later. A football player is moving southward. A football player is moving southward. We know that this is north, this is east. So he is moving southward. Suddenly he turns eastward. Suddenly he turns eastward. He moves southward. And to avoid a collision, avoid an opponent. He should not hit, This is offense in football. That's why he has to turn east. The force that acts on the player while turning is what force is required to turn him towards east without hitting that opponent? What are the forces acting on it? If he want to avoid that collision, the force acting towards south must become zero. It must become zero means we need an equal and opposite force towards north. Then he has to turn towards east. For that, he needs some force towards east. So the combination of these two will avoid collision with the opponent player. So what is the resultant of this? Resultant of this, how to find, draw a parallel line to this, parallel line to this. Then this is the resultant. That is north, east. So A is the force that acts of the player while turning is along northeast. along northeast. Yeah. Shall I move next some? A ball of mass 0.5, 0.15 kg, mass equal to 0.15 kg, is dropped from a height of 10 meter. Dropped means initial velocity equal to 0. Dropped from a height of 10 meter. Height of 10 meters. And rebounds to the same height. Rebounds to the same height. Here, um, here, what is the initial velocity? U equal to 0. Here, the final velocity will be maximum because of acceleration due to gravity. A equal to G. We can find this velocity. We can find this velocity. If U equal to 0 means we know that V equal to U plus AT. That V, this is 0. That's why V equal to A into G into T. So the velocity will be maximum. If it bounces back to the same height, 10 meter means that V max initial velocity bounce back, bounced initial velocity must be equal to V max, but in the opposite direction, minus V max, minus V max. Then only it will reach 10 meter because while coming down, initial velocity is 0, final velocity is V max. If it bounce back, what will happen? If it bounce back, it has to go to the same 10 meter. Then its initial velocity must be V equal to V max. V must be equal to V max. And the final velocity is again 0. The distance traveled same means both should equal. Initial velocity must be V max, final velocity must be 0. This we got. So the magnitude of impulse imparted to the ball is, what is the impulse is asked. Impulse equal to change of momentum. Impulse equal to, impulse means, example for impulse is hammer blow. Impulse means if you use a hammer to give a blow on any mass, that is called impulse. How to find impulse here? Impulse equal to change in momentum. Change in momentum. Change in momentum. That is called impulse. Change in momentum means while hitting, what is the momentum? Momentum equal to what? P equal to mass into velocity. That is mv. mv. Um, What is that is while hitting that floor, its momentum is mv. What is rebouncing momentum? That is P2 equal to minus V multiplied by M. That is equal to minus MV. What is the change in momentum? Delta P equal to P1 minus P2. That is equal to MV minus of minus MV. That is equal to 2MV. Mass is given, velocity is not given. So we have to find the velocity. To find velocity, let us, here time is not given, but distance is given, S is given. That's why let us use this formula. V square equal to U square plus 2AS. So this U is initial velocity is 0. That's why V square equal to 2 multiplied by A, that is G. S is 10. G is also given, that is 10. In the sum it is given. Therefore, 200. V square equal to 200. Um, Therefore, V max equal to square root of 200. Square root of 200, that is equal to 100 root 2, 10 root 2. 100 multiplied by this 200 can be written as root 100 multiplied by 2, 10 root 2. You substitute this, that is equal to 2 into m equal to 0.15 multiplied by v equal to 10 root 2. That is equal to how much? 2 into 15 equal to 0.3 multiplied by 10 multiplied by 1.41. 1.41 multiplied by 0.3 equal to 4.23. 0.423. Multiplied by 10 equal to 4.23. The answer is C. C is the answer. Shall I move to next sum? Minute. Shall I move next one? So impulse here in this sum, impulse is asked, that is change in momentum. Momentum equal to mass into velocity. Change in momentum means initial momentum minus final momentum. That is change in momentum. mv minus of minus mv, that is 2m. Okay. A stone is dropped from a height h. A stone is dropped from a height h. Stone is dropped. Therefore, dropped means u equal to 0. It hits the ground with certain momentum, mv, p equal to mv. If the same stone is dropped from a height 200% more than previous, it is dropped from 2h, 100% more than means 2h. What is the momentum? mv2, p2 equal to mv2, p1 equal to mv1. Then the momentum will hit the ground will change by how much percentage? We know in the previous sum we have seen that momentum p1 equal to mass into velocity. Here h is given. H is given, u equal to 0. Therefore, V square equal to 2AS. V square equal to 2A equal to G, S equal to H. V square equal to, therefore, V equal to square root of 2GH. Therefore, mass multiplied by square root of 2GH. That is P1. P2 equal to what? P2 equal to same mass, but velocity equal to what? 2G, 2H. That is equal to mass into square root of 4GH. What is the ratio? P1 by P2 equal to M root 2GH divided by M square root of 4GH. M getting cancelled, GH also getting cancelled. That is equal to root 2 divided by 2. That is equal to root 2 divided by 2. Equal to how much?
1 by root 2, sir.
Sorry. Root 2.
1 by root.
Yes, yes. P1 divided by P2 equal to 1 by root 2. 2 can be written as root 2 multiplied by, yes, yes. Root 2 can be written as root 2 multiplied by root 2. That's why root 2 getting cancelled. Therefore, 1 by 1.41. P1 by Pt equal to. Therefore, P2 equal to 1.41 P1. 1.41 P1. So what you will get is P2 equal to momentum of 2 equal to 1 means 100%. 0.41 means 41%. Therefore, P2 is 41% higher than P1. Shall I move to next sum?
Yes, sir.
Sand is being dropped on a conveyor belt. Conveyor belt means if you want to continuously transfer some material from one point to another point, this conveyor belt will be used. Conveyor belt will be used to transfer from one point to another point. So this will, if you drop some material here, it will be transferred here. That is called conveyor belt. It transfers the material at the rate of m kg per second. This is called a mass flow rate. Mass flow rate. The force necessary to keep the belt moving with constant velocity v will be the force necessary to keep the belt moving with constant velocity v will be what is the force required? We have to find force required. We know that the momentum equal to P equal to mv. We know force equal to dp by dt equal to force. First, let us find momentum. Momentum dp by dt. That is equal to, if you differentiate this with respect to time, that's why m into dv by dt plus v into dm by dt. So, but the velocity constant rate, the rate is m kg, v equal to 0. That's why dv by dt equal to 0. Therefore, force equal to velocity multiplied by dm by dt. dm by dt is given m kg per second and the velocity is v is given. Therefore, v multiplied by m, that is mv Where is that answer? MV Newton. Therefore, C is the answer. Shall I move to next sum?
Yes, sir.
Yes, sir.
A cricketer catches a ball of mass 150 gram, mass equal to 150 gram, that is equal to 0.15 kg. Time 0.1 second. He catches in 0.1 second. Moving at a speed equal to velocity equal to 20 meter per second. 20 meter per second. Then force equal to what? Force equal to force equal to mass into acceleration. Force equal to mass is given. Acceleration we can find. Acceleration equal to what? Change in velocity v2 minus v1 divided by delta t. The velocity, the ball is coming at the speed 20 meter per second. After catching, its velocity becomes zero. Therefore, initial velocity is initial velocity is 20 meter per second. Final velocity is 0. 0 minus 20 divided by what time? 0.1 second. Therefore, minus 200. Retardation. That's why we are getting in minus. Minus 200 meter per second square. Meter per second square. If you substitute here, the force equal to 0.15 multiplied by 200, that is equal to 30. 30 Newton. Therefore, B is the answer. B is the answer. Why they are giving 300? If you use 150 as such, what you will get there? That's why this 300 and all given. 0.3, 300, these are all given. Whether you know that conversion or not. Shall I move to next sum?
Yes, sir.
Yes, sir.
A bullet is fired from gun. A bullet is fired from a gun. This is the gun. From that, a bullet is fired. And the force on the bullet is given by F equal to the force given here, F equal to 600 minus 2 into 10 power 5 t. 10 power 5 t. Yes, 10 power 5 t. F is in Newton and t in seconds. This is in seconds. This is in Newton. Newton, this is in seconds. That is given. The force on the bullet becomes zero as it leaves the barrel. This part is called barrel. Barrel. Initial push only given. The velocity, sorry, the force F while leaving the barrel is zero. F equal to zero. What is the average impulse imparted on the bullet? That is asked. We know that F equal to dp by dt. Force imparted. The force on the bullet becomes zero as it. What is the average impulse? If you ask impulse, we have to find change in momentum. Change in momentum. That is dp by dt equal to force. But the average impulse imparted is asked. That's why We have to find multiply this on both sides. We'll get dt f dt equal to dp. The momentum p equal to p is the impulse. Hmm, p equal to integral of f dt because f is given. We have to find p to find impulse. We have seen this earlier also. Where is the impulse is asked. Impulse imparted. So impulse is change in momentum. Hmm, From that we find impulse imparted. We found here. So P we have to find. That's why we know that here F is given. That's why we cannot substitute MV here. So F has to be used. That's why, which is some 11th. Yes, 11th, then 13th. Okay. So F is given. That's why we need P. But we know that F equal to dP by dt. One sum also we solved like this. So therefore we want P. That's why multiply on both sides dt, you will get F dt equal to dP or P equal to integral of F dt. But integral we need a limit. So we initial time we know t equal to uh, 0 seconds. Initial time we know t equal to 0. What is the final time when it will leave the barrel? But equation for force is given. Equation for force is given. F equal to 600 minus 2 into 10 power 5 t is given. This is the force. This becomes 0 when it leaves the barrel. That's why F equal to 0 if we substitute 600 minus 2 into 10 power 5 multiplied by t. Therefore, t equal to 600 divided by 2 into 10 power 5. That is two zeros getting cancelled. That's why this becomes 0. That is equal to 3 into 10 power minus 3 seconds. 3 milliseconds. 3 milliseconds. So we have to integrate up to 3 into 10 power minus 3. We got. Now we have to integrate f. Integrate f means what? F equal to what? 600 minus 2 into 10 power 5 t dt. dt integrate from 0 to 3 into 10 power minus 3. If you integrate what you will get? If you integrate 600, you will get 600t minus 2 into 10 power 5. T if you integrate t square divided by 2. Limit, what is the limit here? Limit is from 0 to 3 into 10 power minus 3. Substitute 3, you write in milliseconds. Or you need P, no? That's why we'll substitute T equal to, here let us write. Let us write here. 600, upper limit is 3 into 10 power minus 3, sorry. 3 into 10 power minus 3 minus 2 into 10 power 5 multiplied by t square 9 into 10 power minus 6. That's all. So 600 10 power minus 3 means 18. This is equal to 1.8. This is equal to 1.8. This is equal to what? 10 power minus 6, 5 minus 1. This is equal to divided by 2 is there. 2 getting cancelled. That's why 0.9 minus 0.9. That is equal to 1.8 minus 0.9 equal to 0.9 Newton second. Therefore, The average impulse is 0.9 Newton second. Therefore, D is that. Shall I move to next sum?
So can you explain last step?
Okay, okay, I'll explain. No problem. So, P we have to find P equal to integral of f dt, that is 0 to 3 into 10 power minus 3. We have to integrate, that is equal to 600 minus 2 into 10 power 5t. We have to integrate this with respect to time. That is equal to how much? 600t minus 2 into 10 power 5 t square divided by 2. 2 getting cancelled. Limit is 0 to 3 into 10 power minus 3. That is equal to how much? Therefore, P equal to change 600 upper limit only. Lower limit is 0. That's why we can leave 600 into T. That is 3 into 10 power minus 3 minus 10 power 5 into T square. Therefore, 9 into 10 power minus 6 divided by 2. 2 getting already cancelled. That's all. So, this is 10 power minus 3 means 2 0 cancelled, minus 1 is there, 1.8. Minus 10 power 5, 10 power 6, 10 power minus 1 is there. 10 power minus 1 is there, 9 means 0.9. Therefore, 0.9 Newton second. Therefore, D is the answer. Shall I move to next sum?
Yes, sir.
Yes, sir.
A force of 6 Newton acts on a body at rest. At rest means U equal to 0. A mass equal to 1 kg. Mass equal to 1 kg. During this time, the body attains a velocity V equal to 30 meter per second. The time for which the force acts on the body is the force equal to force equal to F equal to 6 Newton. What is the time as asked? We know that F equal to mass into acceleration. That is equal to mass equal to 1 kg. Acceleration video is not given, but velocity is given. Initial and final velocity is given. Therefore, V minus U divided by time. So from this, we can find the time. F equal to given 6. Therefore, 6 equal to 1 multiplied by V equal to 30 minus U equal to 0 divided by T. Therefore, T equal to 30 divided by 6 equal to 5 seconds. Therefore, B is the answer. Shall I move to next sum?
Yes, sir.
A force vector applied on the mass is represented as F equal to 6i minus 8j plus 10k. These are all unit vectors. A force vector applied on mass. It means what? A mass is there. In this direction, 6 Newton is applied. In this direction, minus 8. That's why I'm putting downward. 8 Newton is applied. Along Z direction, 10 Newton is applied. The resultant of this is the total force applied on this. This is the meaning. That's why 6. This is I direction. This is I direction. This is J direction. This is K direction. Is applied. Minus J direction. A force vector applied on the mass is represented as F and accelerates to 1 meter per second. A equal to 1 meter per second square. What will be the mass of the body? We know that F equal to ma. M equal to mass is asked, F divided by A. But mass is scalar. So we cannot use F. Instead, we have put the modulus of F. Modulus of A. Modulus of M is required. So modulus of F equal to what? Square root of 6 square plus 8 square plus 10 square divided by A equal to 1. That is equal to square root of 36 plus 64 plus 100 divided by 1. That is equal to square root of 100 multiplied by 2 divided by 1. That is equal to 10 root 2. 10 root 2 is C is the answer. Shall I move next sum? To find a modulus, we have to put the square root of magnitude square. Sum of magnitude squares. A satellite in force-free space. Force-free space. Force-free space. Force-free space. Sweeps stationary interplanetary dust at the rate of dm by dt. Dm by dt equal to alpha v is given. Where m is the mass and v is the speed of the satellite and alpha is a constant. The acceleration of the satellite is asked. Acceleration of the satellite is asked. We know that F equal to mass into acceleration. We know that the mass into acceleration is F. We also know that F also equal to dp by dt. That is equal to P equal to what? P equal to mv. That's why m into dv by dt plus v into dm by dt. That we got. Here, velocity is constant. Velocity is constant. That's why this is equal to 0. That's why dp by dt equal to v into dm by dt. That's why if you substitute this, what you will get is F equal to ma. We have to substitute. This is 3. This is 3. Acceleration is asked. Acceleration is equal to what? If you compare 2 and 3, we will get ma equal to v into dm by dt. This implies ma equal to v into dm by dt equal to alpha v. Therefore, what you will get is ma equal to alpha v square or a equal to alpha v square divided by m. Alpha v square divided by m. Here force free space, no force. That's why it is a deceleration. That's why minus sign. That's why minus sign. That's why minus sign. Eh? Hmm. That's why minus sign. A equal to minus alpha. All has minus sign. That's why don't worry. You didn't understand this. If they give 1 plus 1 minus, then only you have to worry. But the acceleration equal to minus alpha v square divided by m. Deceleration. That's why minus alpha v square divided by m. Shall I move to next sum? A 600 kg rocket is set for vertical firing. Mass equal to 600 kg. Set for vertical firing. So the rocket is set for vertical firing. The exhaust speed is 1000 meter per second. The mass of the gas ejected per second supply the exhaust needed. Mass of the gas, why it is going upward? The mass is ejected. The gas is ejected from this rocket. That's why it's going upward. What is the mass of the gas is ejected per second? dm by dt is asked. This, it is identically equal to previous sum. The previous sum, what we have seen, um, f equal to dp by dt. dp by dt, that is equal to p equal to mv. Therefore, m into dv by dt plus v into dm by dt. In this case, this is equal to 0. Velocity is, exhaust speed is 1000 meter per second is given. That's why v into dm by dt. Therefore, velocity is given. V, mass of the gas per second to supply the exhaust needed. F equal to ma also we know. Ma. Mass of the gas per second is required. dm by dt we would find. That is dm by dt equal to F divided by V. F equal to ma. Against gravity, it's going. That's why we can substitute F mass into acceleration instead of F divided by V. That is equal to mass is how much? 600. Acceleration is 10 divided by V is 1000. Therefore, that is 6 kg per second. Therefore, C is the answer. Shall I move to next sum? The body of mass M, body of mass M hits normally at rigid wall with velocity V and bounce back with the same velocity. So this is hits a mass, hits with velocity V and bounce back with the same velocity. V bounce equal to minus V. V impact equal to V. So V impact equal to V. V bounce back equal to minus V. The impulse experienced equal to delta P, that is equal to P2 minus P1. P1 minus P2. Change in momentum, that is equal to mv minus of minus mv. Why? Because the velocity v is minus. Minus m, that is equal to mv minus of minus mv, that is equal to 2mv. Therefore, C is the answer. Impulse means delta P. Impulse means delta P, we would find. Shall I move to next sum? Shall I move to next sum? Martha?
Yes, sir.
Okay. A body of mass 3 kg, mass equal to 3 kg, hits a wall at an angle 60 degree. This is the wall. It hits the wall at 60 degree. 60 degree and returns at the same angle. So it returns at the same angle 60 degree. The impact time was 0.2 seconds. Time equal to 0.2 seconds. 0.2 seconds. The force exerted on the wall equal to how much? The force exerted on the wall equal to how much? We know that F equal to dP by dt. That is equal to m into dv by dt plus b into dm by dt. Here there is no change in mass. That's why this is equal to 0. Therefore, mass equal to 3, dv by dt can be approximately written as delta v divided by delta t. dv by dt means change in velocity with respect to time. But this is very small, infinite small. This can be approximated to known change dv by delta v by delta t. We can replace. But anyhow, it is approximate value. Delta v by delta t. So, what is the time is given? In 2 seconds is given. Here, we have to resolve this into two components. One is velocity hit the wall at 60 degree, returns at the same angle. That's why we have to put um, a minute. A body of mass 3 kg hit a wall at an angle 60 degree and returns at the same angle. The diagram is not given. Sorry. The diagram is there in the question. There he wrote V equal to 10 meter per second. And that's why I'm worrying. V equal to 10 meter per second. It is in the diagram. 10 meter per second. So change in velocity we have to find. It hits at 10 meter per second. That's why we have to resolve this into two components. One is cos component, that is along wall, that is equal to 10 cos 60. Another component, vertical component, that is going this way, that is 10 sin 60. While returning, it is bounced back with the same angle, that is also equal to bounce back with the same angle. That's why that is 10. This is cos 60, and this return is 10 sin 60. Sin 60. This sin 60 is towards east. This is towards west. That's why these two getting cancelled. So only the velocity cos component is there. Both are in the same direction. Here the cos component is upward. V cos 60. Here also it is upward. V cos 60. Mm, that's why these two getting cancelled. The cos component getting cancelled because delta V means change in velocity. Therefore, we can write here the direction is 10 cos 60. That is in the direction of J. So we can put J. Sine component towards left. Therefore, we can put I. So 10 sine 60 minus I. Therefore, we can put a minus sign here. This is velocity approaching, leaving again 10 cos 60, same direction J. Sorry, initially it is positive. Towards initial along x direction. That's why plus I. Plus I. Bouncing back means minus 10 sine 60 I. So we are subtracting. That's why the cos component getting cancelled. Therefore, F equal to delta P divided by mass 3 into dV by dt. That is 10 sine 60 minus of minus plus 10 sine 60 I along I direction divided by delta T. Time is 0.2 seconds. Therefore, sine 60 equal to root 3 by 2. Therefore, 3 multiplied by 2 multiplied by 10 root 3 divided by 0.2 multiplied by 2. 2 getting cancelled. This is root 3 multiplied by 3. Root 3 multiplied by 3 multiplied by 10 equal to how much? This is 50. 50. 3 times 50 is 150. That is equal to 150 root 3. 150 root 3. A is the answer. 150 root 3. Therefore, A is the answer. Shall I move to next sum? So here it is suppose if you put perpendicular to this means 10 and bounce back also 10, because let us assume that elasticity equal to 1, E equal to 1. Here we are assuming E equal to 1. E is not given, that's why we are assuming E equal to 1. That's why it is written back at same velocity. 10, 10, that's why 10 minus of minus 10, 20 you will get. But here it is inclined. That's why two components. One is cos component and sine component. Cos component getting cancelled because of minus sign. But sine component, one is towards east, another one is towards west. That's for minus of minus plus. It is added together. So 150 root 3. Shall I move to next sum?
Yes, sir.
An object flying in air with velocity 20I plus 25J minus 12K suddenly breaks into two pieces. Object flying in air with velocity v equal to 20I plus 25J minus 12K. Its velocity is given. Suddenly breaks into two pieces with the masses are in the ratio, masses and the ratio M1 is to M2 equal to 1 is to 5. M is break into two pieces, M1 and M2, 1 is to 5. The smaller mass flies off with the velocity, smaller mass M1 flies with the velocity of M1 equal to 100I plus 35J plus 8K. We have to put this cap, I am not used to. You assume that cap is there. 100I plus 35J plus 8K. And the velocity of larger piece will be, what is the velocity of larger piece? V M2 equal to what? That is asked. In this case, we know that momentum before equal to momentum after. That is P before equal to P after. That is equal to P before is MV. That is equal to P after is M1V plus M2, M1V1 plus M2V2. M is given, M is not given, but M1, M2 ratio is given. M1 is to M2 is 1 is to 5. Therefore, M1 divided by M2 equal to 1 by 5 or M1 equal to 5 M1 equal to M2. 5 M1 equal to M2. So we can substitute M M total how many pieces? 6 pieces. If you put 6, 1/6 is M1. Therefore, M1 equal to 1 by 6 M. M2 equal to 5 by 6 M. Totally, the ratio, if you add these two together, you will get to 6. Therefore, M divided by 6, 1 by 6 is M1, 5 by 6 is M2. So we can substitute all this. Here the velocity is 20I plus 25J minus 12K equal to M1, 1 by 6 V1. V1 is given 100I plus 35J plus 8K plus M2, 5 by 6 M V2. That we have to find. We have to multiply on both sides by 6 and cancel M. You will get 5 times V2 equal to 5 times V2 equal to, we have to multiply this by 6. That's why 120 I minus 150 150J 72K. This is, we have to subtract this, minus 100 I minus 35J minus 8K. So what you will get, 120 minus 100 equal to 20I. The answer is 20I minus 185 minus 185J 72 80K minus this 150 is plus, plus, so 115J 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 plus 115J minus, both are minus. That's why 80K. That is equal to how much? 5V2. Therefore, V2 equal to 4I. V2 equal to 4I. If you divide this by 5, 23 plus 23j, um, 5 if we divide 18, 18k, 18k, 16k, sorry, 16k. 4i plus 23j minus 16k. Where is the answer? Yes, A is the answer. Shall I move to next sum? Shall I move to next sum?
Sir,
Hmm? Yes.
5v2 is equal to 120i plus 150j. How it
Yeah.
is coming?
Oh, nice. We are multiplying on both sides by 6, you know. Here divide by 6, you know. To
Okay,
cancel
sir.
that 6, we are multiplying this by 6 on both sides. Got?
Yes, sir.
Good. Shall I move to next sum?
Yes, sir.
A 1 kg stationary bomb. 1 kg stationary bomb. Mass equal to 1 kg. Mass equal to 1 kg. Exploded into 3 parts. M1, M2, M3. That is equal to 1 is to 1 is to 3. So, 5. M1 equal to 1 by 5 M. M2 equal to 1 by 5 M. M3 equal to 3 by 5 M. So, the stationary bomb is exploded into 3 parts having mass 1 is to 1 is to 3 respectively. Parts having same mass move in perpendicular direction. Let us assume that they are perpendicular to each other, M1, M2. Therefore, let us assume that it is moving along I direction. Let us assume that it is moving in J direction. Sorry. Parts having the same mass having move in perpendicular direction with velocity 30 meter per second. So velocity of M1 equal to 30I. Velocity of M2 equal to 30J. That's all. That is given. 30 meter per second J. Then velocity of bigger part will be. What is the velocity of M3 is asked. We know that momentum before equal to momentum after. Momentum before is mass into velocity. That is equal to M1 V1 plus M2 V2 plus M3 V3. So stationary bomb, it is given. Therefore, V equal to 0. That's why we can say that 0 equal to M1. M1 is what? 1 by 5. 1 by 5. V1 is 30I plus M2 equal to again 1 by 5 30J plus M3 V3. M3 equal to 3 by 5. That is given. 3 by 5. M. In everything, M is there. That's why we can take M outside. That is not equal to 0. Therefore, 1 by 5 30I plus 1 by 5 30J equal to minus 3 by 5 V3. We have to find V3. 5 also getting cancelled. 5 also getting cancelled. Divide by 3 means 10I plus 10J equal to V3. Here we can find only magnitude. Therefore, V3 equal to square root of 10 square plus 10 square, that is equal to square root of 100 multiplied by 2, that is equal to 10 root 2. Therefore, A is the answer. Shall I move next sum?
Yes, sir.
A shell in flight explodes into 4 equal parts. M1, M2, M3 equal to M4. Which of the following is conserved? Momentum is conserved. By momentum only we are finding, no? That's why momentum is conserved. So 33, we can say that the momentum is conserved. P before equal to, we are previous sum, P before equal to P after. Therefore, momentum is conserved. Shall we move to next sum?
Yes, sir.
A body of mass 5 kg explodes at rest into 3 fragments. A body of mass 5 kg, mass equal to M equal to 5 kg. 3 segments, M1, M2, M3. In the ratio 1:3. M1 equal to 1 by 5 M. M2 equal to 1 by 5 M. M3 equal to 3 by 5 M. With equal masses fly in mutually perpendicular direction with a speed of 21. The same sum, instead of 30, here it is given as 21. Therefore, body of mass explodes in rest. Initial velocity is rest. Therefore, mv equal to m1 v1 plus m2 v2 plus m3 v3. This is equal to 0. Therefore, 0 equal to m1 is 1 by 5 m. v1 is 21 meter per second along I direction, mutually perpendicular. Another m2 is 1 by 5 m, 21 j plus m3 v3. Therefore, m3 v3 equal to m3 is 3 by 5. Sorry, 3 by 5 m. So left side 0. That's why this 5 getting cancelled. M also getting cancelled. 3m. M also getting cancelled. Therefore, V3 equal to 3V3 equal to minus 21I minus 21J. Therefore, V3 equal to minus 7I minus 7J. Therefore, V3 equal to square root of 7 square plus 7 square. That is equal to square root of 2 multiplied by 7. That is equal to 7 square. That is equal to V3 equal to 7 root 2. 7 root 2. Therefore, A is the answer. A is the answer. Shall I move to next sum?
Yes, sir.
3 forces acting on a body are shown in figure. The figure is not given. That's why let us draw 3 forces acting on the body. This is the body. It is 3 forces acting. 2 Newton acting in this direction. The angle is 60 degree. And 1 Newton acting along this direction. 1 Newton again 60 degree with the x-axis. This is minus 60. Here this is minus 60 is not given. Simply in the diagram, the 60 is given. This is given 30 degree. 30 degree. Here, how much? 4 Newton. 4 Newton. This is 30 means this is 60. This is 60. So what is asked? To have a resultant force only along y direction. This is x direction, this is y direction. The resultant force must be along y direction only, not along x direction. The magnitude of minimum to have the resultant force. Three forces acting on the body are shown in figure. To have the resultant force only along y direction. The resultant force must be along y direction only. The magnitude of minimum additional force needed is additional force how much needed. So, the forces acting along x direction must be 0. Fx must be 0. Fx must be 0. Sum of Fx equal to what? Must be 0. Sum of Fx equal to the additional force along the additional force only. The minimum additional force needed is that must be in along x direction. If it is not 0, automatically if it is 0, resultant will be y direction. If it is not so, we need a force which should be added in the x direction so that all x direction force equal to 0. What is the sum of x direction forces equal to sum of x direction forces equal to this is 1 Newton 1 cos 60 plus direction. So plus I direction. Then this is also along x direction plus 2 cos 60 along I direction. This is opposite to that. That's why minus 4 cos 60I plus Fx has to be added so that this is equal to 0. So what you will get? Cos 60 equal to what? Root 1 by root 2. 1 by root 2 I plus 2 by root 2 I minus 4 by root 2. Sorry. Cos 60 equal to root 3 by 2. Cos 60 means, sorry, 1 by root 2. 1 by root 2 plus Fx equal to plus 1 by 2. Yes. Wait. I didn't remember this angle. I didn't. You have to memorize. I'm old man. Okay. Anyhow, cos 60 1 by 2. How to remember this? 30, 0, 30, 45, 60, 90. So we have to write 0, 1 by 4, 1 by 2, 3 by 4, 1. If you take square root of this, you will get the sine. Sine 0, 1 by 2 square root 1 by 2, cos 1 by root 2, sine 45 equal to 1 by root 2, sine 60 equal to root 3 by 2, 1. Cos reverse 1 root 3 by 2, 1 by root 2, 1 by 2, cos 60 is 1 by 2. So, tan means we have to find the ratio of this. You will get 0. If you divide 1 by root 3, if you divide 1 here, you will get a root 3 infinity for tan. I didn't remember. Please, you memorize this and So 1 by 2. So what you will get is 1 by 2i plus 2 by 2i minus 4 by 2i plus fx equal to 0. Therefore, all 2 you can cancel because right side is 0. So 2fx equal to 2fx equal to this is 3i minus 4i equal to uh, 4 minus 3 1i. So I you will get. Therefore, fx equal to 1 by 2i. So fx equal to 1 by 2i or 0.5i. That is equal to 0.5 Newton. C is the answer. 1 by 2i is needed to make force along x direction equal to 0. All x direction forces must be 0. Then only the resultant force will be along y direction. Shall I move to next sum? Shall I move to next sum?
Yes, sir.
Calculate the maximum acceleration of a moving car so that the body lying on the floor of the car remains stationary. Hmm. A car is moving. Car is moving. On its floor, one mass is there. Remain stationary. What is the maximum acceleration so that this mass should not move? The coefficient of static friction between the body and floor is 0.5. So this coefficient of friction here is mu equal to 0.15 is given. G given. G is equal to 10 is given. What is the acceleration of the car? So here we have to write what are the forces acting on the mass. Downward mg is acting. Normal force n equal to also mg because it is equal to, both must be equal. Here, let us assume that car is moving towards the right. Therefore, a force is applied here by the car because of acceleration. Acceleration is proportional to F, mass into acceleration. This acceleration is given by the car. What is that? The minimum acceleration required we would find. Therefore, in this direction, force equal and opposite force will exist. Third law. So that that must be equal to. We know that this frictional force equal to mu multiplied by n. That is equal to mu mg is there. Therefore, ma equal to mu mg. We got horizontal force if we resolve. Vertical forces mg equal to mg. That is not required. But ma equal to mu mg we got. M getting cancelled. Therefore, A equal to mu g. That is equal to mu g means mu equal to 0.15 multiplied by g equal to 10. Therefore, 1.5 meter per second square is the maximum acceleration. Beyond that, this force will be more. Right side force will be more. If acceleration increases, this is less, this is more. That's why it starts moving. Maximum. So 1.5 meter per second square. Therefore, A is the answer. Shall I move next sum?
Yes, sir.
A plank with a box on it at one end is gradually raised. A plank one end is gradually raised. This end is raised. This is on the floor. This is floor. Gradually raised about another end as the angle of inclination with the horizontal is 30 degree. 30 degree. The box starts slip, slides. The box starts slides down 4 meter down the plank in 4 seconds. The coefficient of static and kinetic friction between the box and plank will be respectively what? The coefficient of friction is mu. We have to find. Static friction means we have to find depends upon this angle. That static mu s equal to tan 30. That is equal to tan 30 equal to 1 by root 3. 1 by root 3. That is equal to 0.6. 0.6. So static friction. Static is first test. Therefore, here only 0.6 is there. That's why without calculating dynamic, we can say that C is the answer. How this tan 30 came? When it tends to move, it is not moving. When it tends to move, we have to find the static friction. That is equal to what? Net force on the box equal to downward is mg. If you resolve this angle also 30. mg cos 30. Upward what? Normal. Normal also equal to mg cos 30. This is tends to slip down because of acceleration. That's why reaction, frictional force will act in this direction. That is equal to mu mg cos 30. Mu into n, therefore mu mg. Now it is tends to move, therefore mu s mg cos 30. Therefore, we can say that mu s mg cos 30 equal to opposite side. This force is mg sin theta. mg sin 30. Why? Because mg is acting vertically downward. If you resolve into two components, one is mg sin theta, sin 30 and mg cos 30. Therefore, that is equal to mg sin 30. Therefore, mg getting cancelled. Therefore, mu s equal to sin 30 divided by cos 30. That is equal to tan 30. That is equal to 1 by root 3. That is equal to 0.6. So, static friction we got. Dynamic friction we have to find. To find the dynamic friction, a force is come into picture, downward force, plus ma, mass into that force F is comes into picture. That is because of mass into acceleration. Mass into acceleration. So that ma is comes into picture. That's why the downward is ma plus mg sin 30 equal to the upward is mu dynamic dynamic mg cos 30. So everywhere m is there, so m getting cancelled. Therefore, a equal to mu dynamic. A equal to m dynamic cos 30 minus mg md cos 30 minus g sin 30. A equal to this, but A equal to we have to find. To find A is giving that it came down to 4 meter in 4 seconds. It is given. Therefore, we have to find the acceleration. We know that S equal to ut plus of AT square. This is 0. Therefore, S is given 4 of A T square in 4 second, 4 square. And therefore, these two getting cancelled. 2 equal to 4A. That is therefore A equal to 2 by 4. That is equal to 1 by 2. The acceleration equal to 0.5. You solve yourself. 1 by 10 equal to 1 minus mu d root 3. Therefore, mu d root 3 equal to 1 minus 1 by 10. That implies mu d equal to 9 by 10 root 3. That is equal to 0.9 divided by root 3. That is equal to 0.5. That is equal to 0.5. Therefore, C is the answer. Check yourself. 0.5 is the answer. Shall I move to next sum? Check yourself. The equation is this. Downward MA plus mg sine 30. These are all downward forces. Upward force mu dynamic mg cos 30. That's all. If you solve this, you will get mu d equal to 0.5. Mu d equal to 0.5. Okay. Shall I move next sum?
Yes, sir.
Okay. A system consists of 3 masses, m1, m2, m3. M1, M2, M3 connected by a string passing over a pulley P, as shown in figure and the horizontal table. A system consists of 3 masses connected by a string passing over a pulley P. The mass M1 hangs freely and M2, M3 are on a rough horizontal table. This is the table, rough horizontal table. In that M2 and M3 are on the table. They are connected by a string passing over a pulley, and this is M1. This is M1. M1 hangs freely and M1, M2 are on the rough horizontal table. This M1, the coefficient of friction equal to mu. Here it is mu. Here also it is mu. So the downward acceleration of mass M1 equal to what? Downward acceleration of mass M1 equal to what? That is asked. So here, what is the force acting downward? M1G. So the string must have M1G in the upward. Here in the opposite direction must be M1G. Must be in this direction. M1G. M1G. What are the forces given by this M2? The opposite forces given by this mass is, what are the forces acting on that M2? This is M2. M2. Downward is M2G. Therefore, normal force equal to M2G. It tends to move towards right. That's why towards left, the force is mu N. That is equal to mu M2G. Therefore, the force given by M2 towards left is mu M2G. Similarly, this also mu M3G. These are all acting on the string Therefore, the force that is acting towards the right is F right equal to M1G. F left equal to M2G multiplied by mu and plus mu M3G. These are all must be equal because what is the downward acceleration is asked. Downward acceleration is asked. First, let us find the net force. Net force equal to that is downward. That's why this M1G is positive, these two are negative. So M1G minus mu M2G minus mu M3G is the net force. Net force equal to this. We know that force equal to mass into acceleration. Therefore, therefore, MA, let it be second equation, let it be first equation. And another relation is given. M1, M2, M3 equal to M. That is also M. Therefore, MA equal to, therefore, MA equal to, instead of M1, we can put M. Mg minus mu Mg minus mu Mg. Or M getting cancelled. All M getting cancelled. Therefore, A equal to G into 1 minus 2 mu or G into 2 mu divided by M. M1 equal to M2 equal to M3 equal to M. But total mass M, M equal to what? M equal to M1 plus M2 plus M3. All forces, that is mass into acceleration. That's why M1 plus M2 plus M3, that is 3M. Therefore, divided by 3. Total mass is 3M. Total mass is 3M. While finding acceleration, we have to consider all masses. So 3M, therefore 3. Therefore, C is the answer. C is the answer. So, for the entire system, if you consider, then all three masses you have to consider. Therefore, M and the left hand side M equal to 3M. M1, M2, M3 equal to M, therefore 3M. Therefore, divided by 3. G into 1 minus 2 mu divided by 3. Shall I move to next sum?
Yes, sir.
A conveyor belt is moving at constant speed. Conveyor belt. This is the conveyor belt. Conveyor belt. The speed is 2 meters per second. The box is gently dropped on it. One box is gently dropped on it. The coefficient of friction between the mu equal to, here mu equal to 0.15. The distance that the box will move relative to belt before coming to rest is. Because u equal to 0, initial velocity, but belt is moving. That's why this will not be rest. Initially it moves, then comes to rest. Then comes to rest. The distance the box will move relative to the belt coming to rest. This box will move towards this direction for some time, then it becomes rest. So what is that? The distance is asked. Now let us solve this sum. What is the force acting downward? Mg. Therefore, normal force also equal to mg. This moves towards this means mu mg will acting towards this direction. This F equal to mass into acceleration. Therefore, that the mass into acceleration must be equal to mu mg. That mass getting cancelled. Therefore, A equal to mu g we got. A equal to mu g. But A we do not know. Let it be 1. We know that V square S we have to find. V square equal to U square plus 2A S. The initial relative velocity is 2 meter per second because belt is moving at the rate of 2 meter per second. That's why U is 2 meter per second. 2 square. V square equal to 0 because finally it has to come to rest. Plus 2. A equal to just now we got mu g. This is retardation. That's why minus mu g multiplied by S. Therefore, we got minus mu equal to 0.15, g equal to 10. Therefore, minus 0 equal to 4 plus 2 minus 0.15 multiplied by 10 multiplied by S. Therefore, S equal to 4 divided by 2 into 15, 1.5. Yes?
Mu 0.5.
Mu?
0.5.
Mu? Oh, okay. I remember the previous number. Okay. 0.5. So 0.5. 0.5 into 10 equal to 5. 2 into 5. Okay. S equal to 4 divided by 2 by 5. 2 by 5 equal to 4 by 10. That is 0.4 meter. 0.4 meter. Therefore, A is the answer. The box will move for a distance of 0.4 meter. One more sum. Shall I move to next sum?
Yes, sir.
This is also interesting. That's why I included that even sum also. A block of mass M is contact with the cart C. This is the cart. As shown in figure. The mass M, its mass is small m. The coefficient of static friction between the block and the cart is mu. That is mu. And the acceleration alpha of the cart will prevent the block from falling surfaces. At what is the acceleration alpha? So that this block should not fall. What is the downward force acting on is mg? What is the upward force acting on it? Mg. Normal force equal to. Therefore, the frictional force acting upward is because this is acting downward. Upward force is here mass is acting downward. Here this is the surface. Therefore, the normal force is mass into acceleration. Mass into acceleration. Normal to this is mass into acceleration. Therefore, the frictional force should act to the opposite downward force. That must be mu m alpha. Mu m alpha. Now we know that it should not fall means mu m alpha must be greater than mg. So m also, the small m getting cancelled. Therefore, alpha should be greater than should be g divided by alpha. G divided by mu. Alpha should be greater than g divided by mu. Should be greater than g divided by mu. G divided by mu. Therefore, C is the answer. C is the answer. I think, hope you got it. Once again, I'll tell. This is the cart. A mass is like this. Downward force is mg. If the cart is stand still, u equal to 0, then it will fall. But the cart is moving towards the right with an acceleration alpha. Therefore, force towards the right is mass into acceleration. That is the force acting on right. What is the reaction force? This is surface. Reaction must be m alpha. M alpha. So here it should not fall means an opposite force must be greater than mg. That force must be mu n. N equal to what? This is n. N equal to m alpha. Therefore, mu multiplied by m alpha. So this mu m alpha must be greater than mg to avoid fall of this mass. Therefore, mu m alpha must be greater than or equal to mg. M getting cancelled. Therefore, alpha must be greater than or equal to g divided by mu. Therefore, C is the answer. Shall I move to next sum? Yes. One more sum. 47. In this chapter, totally 81 sums, 83 sums are there, 85 sums are there. So halfway we came. 47. Shall I stop here? Almost 7. 47 we'll see tomorrow. Got this 46?
Yes, sir.
Okay. We'll meet tomorrow.
Thank you,
Thank
sir.
you, Ramesh.